Who would have thought that the sharp eyes of the James Webb Space Telescope could reach the conclusion of the universe? Scientists have just shared a cutting-edge paper that shows the universe is finite after all. Has the Webb telescope accomplished what scientists have failed to do for decades? If the universe is undeniably finite, this knowledge has far-reaching consequences for understanding astronomy and the world in general. The address of the limit or infinity of the universe never seemed fully determined until the James Webb Space Telescope found new evidence. Even Einstein, the incredible virtuoso of material science, was puzzled by the question of the infinity of the universe. When the author questioned Einstein about this, he playfully said, "Two things are infinite, the universe and human idiocy, although I'm not so sure about the universe." We humans have learned one thing throughout our galactic history: we've generally been wrong more often than not. People thought the Earth was flat. Then they thought there was only one sun. They later believed that the Milky Way is the universe. Today, we have become more open to the question of whether or not the universe has an end. Analysts generally left the question officially open because they had to admit that there was no evidence for one or the other.
Liftoff of
Secretly,
the Delta
however,
rocket carrying
the analysts'
blast,
camp split
a
into
gamma-ray
two political
telescope
parties.
searching
On the
for
one hand
unseen
there are those
physics
who can
in
well
the
imagine an
stars of the
infinite
galaxy.
universe, and on the other hand there are those for whom such an idea is out of the question. Since the invention of the Big Bang hypothesis, many analysts have been almost certain that anything that had a temporal beginning must also have a fleeting, spatial conclusion. The Big Bang was a widely accepted truth for nearly a century. The James Webb Space Telescope has shown the existence of dozens, if not hundreds, of galaxies when they shouldn't exist. Ancient truths are disappearing. Analysts have realized that their ancient structures are incomplete, and this is not easy for many, because the beginning of the universe has again become a mere hypothesis without confirmation. But how do analysts now come up with the idea of announcing that the Webb telescope has found proof of space inferences? An infinite horizon is not a conclusion. First, let's find out what the end of the universe really is. We feel the vast horizon. It represents the limit that we can currently observe. That's about 46.5 billion light-years around Earth, resulting in a circle about 93 billion light-years in diameter. If JWST had found evidence of the last edge of the observable universe within this ring, it would have to be a larger zone where light can no longer penetrate, even due to expansion. However, this does not indicate that this is a conclusion. It would only mean that the light in that zone is too far to reach us. Even if JWST found a huge void somewhere beyond the horizon, it still wouldn't be proof of the end of the universe. A void may also simply be larger than the average void we know locally in the observable universe. When they were discovered, they were a challenge to our science. In short, they really shouldn't exist, because there are no such gaps in Einstein's relativity equations. This set of equations continues to be the mother of astronomy today. The only way out of this logical dilemma is that voids are not really empty, but contain something that we cannot see or measure. But let's return to the idea of the observable universe. This conclusion has nothing to do with the end of the true universe, and we have yet to find any sign of an edge or end of the spatial or temporal universe in the observable universe. Only the expansion that we observe almost everywhere in the universe gives any indication. Webb analyzes the expansion of the universe. Let us note again, expansion is a recognized development of the universe since its formation. This beginning is said to have been the Big Bang. The expansion was first observed in the 1920s by cosmologists such as Edwin Hubble. Hubble and his contemporaries were the first to discover other galaxies in the universe. They noticed that distant galaxies seem to be moving away from us, suggesting that the universe is breaking up. This observation and other evidence eventually led to the famous Big Bang theory. Further evidence of this expansion was later found in the cosmic microwave background radiation, but there were also questions. Estimates of the expansion rate led to different conclusions depending on the scales used. The drift of the universe should be relatively the same everywhere. There were also signs that the expansion was accelerating in some regions of the universe, which really shouldn't be. This raised questions about the idea of the expansion of the universe and the existence of a starting point. For a long time, the idea of expansion was also a kind of proof of the temporal end of the universe. Calculations have shown that due to expansion, the universe should one day end in one of three scenarios: the Great Rip, where the universe tears itself apart; Big Freeze, where the universe freezes after expanding too much and using up all its energy; and the Big Crunch, where the universe collapses at one point. The James Webb Space Telescope has now found new evidence that the universe is not directly expanding, and that the idea of expansion may therefore be wrong. This would negate the last three scenarios. Webb introduces Hawking radiation. Did you know that JWST's latest and greatest revelations fueled the cyclical universe hypothesis? That speculation arose from the calculations and observations of British physicist and Nobel laureate Sir Roger Penrose. According to Penrose, the expanding or evolving universe will end at some point in a scenario where the supermassive black holes have swallowed almost all the matter. At this point, the structure of space-time collapses, and for a few moments outside the dimension of time, the universe remains in a kind of zero-point state. Then the new universe begins with a Big Bang. This hypothesis is also largely based on Hawking radiation, which shows that information can come out of black holes again, but in a modified form and in a very small way. During its mission, JWST may provide new evidence for the real existence of Hawking radiation. Stephen Hawking was able to scientifically prove radiation, but there is no actual confirmation. Never before in the history of space science have we been close enough to a black hole to measure these emissions. Perhaps some analysts will be able to accomplish this feat by pointing the JWST spectrometer directly at the event horizon of an ancient black hole. This would provide further confirmation of Penrose's idea of a cyclic universe. Have we reached the multiverse and not realized it? There is increasing evidence in cosmology and astronomy that the true structure and nature of our universe is patterned and multivariate. When we combine the findings of quantum physics with the latest discoveries in space science, the evidence for parallel universes and dimensions becomes more and more concentrated, finally leading directly to the multiverse, a universe of an infinite number of universes. If we ever reached the edge or limit of our universe, it would not really be an end in that sense, but a transition, like a border from one nation to another. In the multiverse, parallel universes separate different cosmological events, but they are also interconnected. Universes can be within universes, which means other universes can be hidden within our own. But it could also mean that our universe is imperceptibly and secretly merging with something else and we haven't recognized it yet. Differences in estimates of the expansion of the universe can show edges like apparent voids or the fact that the unusually old and developed galaxies found by JWST are not actually part of our universe, but a different part. Such a boundary may be characterized by physical incompatibilities or abnormal objects. Physics knows many such limits. Imagine walking across the border of a European country. If there was no border crossing somewhere, you would probably only notice the change in the country in terms of the language of the people, changed street signs or other landmarks. JWST again compares cosmic microwave background data with real events and objects in the universe. Cosmologists say they have read a lot of evidence for the expansion and the Big Bang in the radiation background. Other experts have also found signs of multiverses, or the eternal nature of the universe. What is true? Here new filters and comparisons of data with the best computer systems and telescopes on Earth can provide new insights. One of the largest projects of its kind is full hydrodynamic large-scale structural simulations with all-sky mapping to interpret the next-generation observation, or FLAMINGO for short, the world's largest collaboration of scientists, supercomputers and data from Earth's best telescopes has long been dedicated to large-scale comparisons of data to find critical signatures and features. Project Flamingo simulations have provided a detailed view of the cosmic web of galaxy clusters, filaments and voids, probing the large-scale structure of the universe.